overthinking this whole thing.
Hours where the groundhog could have like.
All right, we're going to work on pretest 5-1 to 5-4.
My groundhog.
What other person? Like a certain percentage.
All right, kids? Everybody's got it out? Now, if we're smart, we got a piece of paper out, and we're working along because you know you're going to have to turn this in. So why don't you just let me do the work, right? However, you should be watching and engaged and learning as we go, because I will not be putting the test on the board for you. I know. Bummer. You'll have to do that one on your own. All right, so here we go. Number 1. Simplify this complex fraction. Now you're thinking, what in the world is this on here for? Because this is a skill you have to have when you're verifying your identities. It doesn't matter how you do this. I'm going to multiply everything by xy. That's the strategy that works best for me. You might have a different strategy, and that is perfectly okay, but ultimately we have to end up with the same answer. Now, on top, nothing cancels for me on the top, so I'm left with x squared y minus xy squared. But what happens on the bottom, and this is why I did this. The x's cancel, and all I have left is y. And then the y's cancel, and all I have left is x. Now, do you notice anything about my problem at this point? We can factor. What can we factor here? Take out an x and a y. And I will be left with what? If I take out an x and a y, I would be left with x minus y. Now, these two are going to cancel. I don't know if we've run into something like this or not. These two are going to cancel. But what do they leave? Not 1. They don't leave a 1. What do they leave when we cancel them? A negative 1. They're opposites of each other. Would you agree? It's like canceling a 7 and a negative 7. You're left with a negative 1. These guys are negatives of each other. So the answer to the problem is just negative xy. So had the x's and y's been sines and cosines, you would do everything exactly the same and end up with negative sine cosine or whatever. All right, now we got some proofs. I think I copied that right. It's kind of hard to read that one. All right, what do you think here? That's kind of a tough one. Millie.
Could you substitute cotangent for cosine over sine and then?
Oh, wait a second, Millie. I love your idea. Let me get caught up with you, and then you can continue. So cotangent squared is cosine over sine squared, and this is just cosine squared over 1. Okay, Millie. Then what?
I was going to change cosine into.
You got a couple fractions, Millie, that are being subtracted. Now notice over here, there's only one term. There's no plus or minus. So somehow we have to get these two terms combined into just one. So since it's a minus, it makes sense that maybe we would do a common denominator, and that would give you one fraction. So let's see what happens if we do that. This one would need to be multiplied by sine squared over sine squared. So now we're going to have cosine squared minus cosine squared sine squared all over sine squared. points for sitting there. Do you see anything you could do to keep this ball rolling? You could factor the numerator, pull out a cosine squared, and what would that leave me with if I pulled out a cosine squared?
1 minus sine squared.
That's going to leave me with 1 minus sine squared, which is cosine squared. So now I've got cosine squared times cosine squared over sine squared. I'm purposefully not combining those because if I combine them, I'd have a fourth, and there's no fourths here. So I'm going to leave those as squared and kind of look at it for a minute. Can I get what I need?
Yeah.
Yeah, because can I break this apart and say cosine squared over 1 times cosine squared over sine squared? Is that a legal move? And that's going to give me cosine squared times cotangent, which is what we wanted. That's a little tougher. Anybody wonder about that? No wondering? All right, how about B? Whoa, what a mess that is. Wow. Well, what do you think? Change everything into sines and cosines and see what happens, because that's what we have over here, so we might as well just see what's going to happen. So we have sine. All right, then we have cosine over sine plus cosine times sine over cosine. These guys are going to cancel. And now, can I distribute? Does that make sense? Distribute the sine. What happens when I take sine times this? I just get cosine, right? And then what happens when I take sine times this? I get sine squared. So I get cosine plus, oh, I'm done. Right? That's it. That's what we wanted. So that looked really awful, but man, that was an easy one, right? Nothing tricky or special about that. Okay, what about the next one? If you decide to work on this side of the equation, clearly you can change your cosecant into 1 over sine and your secant into 1 over cosine, and that makes perfectly good sense since that's what you're trying to end up with. Okay, how many fractions are on that side? 1. How many are on this side? 2. Oh, let's put them together, right? So the common denominator would be sine cosine. This one needs a cosine. This one needs a sign. So now the denominators match, and the top is cosine plus sine. That was another easy one. Now I do want to show you something. We haven't done this a lot, but I want to make sure you're aware that you can do it. You are allowed, if you want, to split that. Obviously, you're going to work on this side, you're going to do it this way. You could have chosen to work on this side. And if you worked on this side, this fraction can actually be pulled apart. It could be uncommon denominator. In other words, sine over sine cosine plus cosine over sine cosine. Does that make sense to you that these are the same thing? So you could have pulled that apart, and when you separate it, see what's going to happen here? It's going to cancel, and you're going to be left with 1 over cosine. And then these are going to cancel, and you're going to be left with 1 over sine. So you could have done the problem pretty easily from that side also, if you recognized you could pull that apart. Eddie? What are we doing on our iPad? Yeah, awesome. But now, right now, what subject was in the Quizlet?
Yeah.
Oh, of course. You think God's more important than pre-cal? So do I, but not in these 45 minutes, okay? So here we go. Tan plus secant equals cosine over 1 minus sine. Last one of these, and we'll move on to something different. All right, so here we go. What is your thought when you look at this? Change these guys into sine over cosine plus 1. Oh, this looks, this is a little harder. I thought it was going to be easy. But this leaves me with sine plus 1 over cosine, right? Which is not what I wanted. What am I going to do now? This one requires a little creativity. Can't square it. That's, unless you could do it to both sides, which you can't. We can't square it. Millie?
Sine x plus 1 equals cosine, and then...
We wish it did. Remember, if they're not squared, we can't do the sine cosine substitutions. They have to be squared.
Multiply both top and bottom by -1. Maybe.
No, but you're close. I don't want to multiply top and bottom by -1, but I do want to multiply top and bottom by something. I'm going to multiply top and bottom by cosine. Now, there are a couple of reasons for this.
I didn't know what I was saying.
There are a couple of reasons for doing that. One is, at this point, I am kind of stuck. There are no identities, no substitutions, nothing for me to do. I notice that somehow I have to have a cosine in the top. This is not cosine. This cannot become cosine. So I'm going to put cosine in the top. Now I have a cosine in the top. What do I have in the bottom? Cosine squared, which can be written as 1 minus sine squared. So I have cosine, sine plus cosine, over cosine squared. That cosine squared needs to become a sine, so I will rewrite it as 1 minus sine squared. So I have cosine, sine plus 1, over 1 minus sine squared. Now, what about 1 minus sine squared? It factors into the difference of squares. And what happens when I do that?
Cancel.
We can cancel, and we are left with what we wanted. That's a tricky one. Not tricky, but you have to be creative because you get to a point where you are literally stuck. There is nothing obvious to do here. So we just said, okay, let's throw a cosine in because I know I have to have one. Let's just throw one in on the top and bottom, and then good things happen from there. Okay. All right, number 3, we're going to solve an equation. We may have already solved this one, but that's okay. We're going to do it anyway. All right, everybody got this so I can erase it? Start this next problem. That got it? All right, let's see if we can get this next one done. Maybe we can. So cosine 2x equals cosine x. Now notice the directions. We're going all the way around the circle.
Which one is this?
It's sine 2x equals cosine x.
Oh, thank you. That'll make a difference in the answers, for sure. All right, so I'm going all the way around the circle. So there could be no answers, 1, 2, 3, or 4 answers, depending on which quadrants we end up in. All right, so what do you think when you look at this problem? What pops into your head? Yeah. Okay, this is trouble. When you have a 2x and a plane x in the same equation, that's bad news. It's like having 2 variables, an equation with x's and y's. We don't want it. So, can we get plane x's? Yes, because sine 2x is 2 sine cosine.
How do we know it's?
Because that's your double angle identity that you're supposed to be memorizing. On the back of your green sheet are the double and halves. Yep, we gotta have them memorized by Wednesday. I will not give you one single formula on Wednesday. You gotta know them all.
Are we allowed to divide by cosine?
Are we allowed to divide by cosine? Now wait a minute. That is a sometimes answer. Sometimes you are. Let me show you when you're allowed to divide by cosine. If you had a problem that said this, you would be allowed to divide by cosine because what you ended up with would be this. And the cosine, you divided by it, but it's still there. The cosine is still there. As long as you divide and don't lose it, you're okay. What would happen over here if we divided is what? The cosine would disappear. And when you lose a function, a cosine or a sine or something, you lose all of the answers associated with that, and then you don't have all your answers then. So the answer is no. If you're dividing to cancel, you cannot do it. All right, we're all packing up like, oh my gosh, I can't wait to get out of here, and I'm not finding this problem very stimulating. All right, so we will start here tomorrow. Remember that your homework is due Monday, but you should pretty much have it done. We're starting on the review work for a test on Wednesday, in which I will give you 0, get that 0 formulas, and you will need to know them all. Okay?